Okay, so we're on section 4 now. So section 4, introduction to complex numbers. So now all the numbers you've seen so far in your life being what we call real numbers. So, well, there's nothing that makes them especially real, except people understand these more. They can picture these easier. So, why is 2.5 real? Well, people can understand 2.5 thousand. For example, 2.5 is 2.5 of something. However, root 2, why is root 2 real? The square root 2. Well, people can imagine that's real because it's the solution to x squared equals 2. So if we think of x squared equals minus 1, well, if people are happy to solve x squared equals 2 and say that answer is real, then x squared equals minus 1, well, why don't we solve that? So x equals, well, that would be one solution because we have plus or minus that. And let's give this number a name. So it's not going to, we're not going to call it a real number, we're going to call this an imaginary number. And we say that that equals what's called I. If you go into anything like engineering, there's something that's called J, but we're going to call it I. So that's what we call an imaginary number. So if I had something like square root minus 4i, we know from our work on surds, I can split that up as root 4 times root minus, just minus 4. I can split up into root 4 times root minus 1. So root 4 gives me 2, and root minus 1 we said is I, so we call that 2i. So again, it's another imaginary number. So we're going to practice just writing numbers in imaginary number form. So let's have root minus 36. See if you can pause it and try it yourself. We rewrite that as root 36 times root minus 1. Root 36 is 6. Root minus 1 we call I, so it's 6i. 6 lots of that imaginary number. So it might be hard to picture that number because it's imaginary. However, that's the new name we give it. Root minus 28. Well, we can write that as root 28 times root minus 1. Well, we know from 4, we can write that as root 4 times root 7 times root minus 1. So we get 2 root 7 I. Yeah, we might want to put brackets around that to make sure that the I is not part of the square root. But it's as simple as that. Okay. Now, another thing we can do is we can put real numbers and complex numbers together, imaginary numbers. So 4 is a real number, 2i is an imaginary number, but if I add them together, I get what we call a complex number. Yeah, and complex numbers are very similar to having something like this. Yeah, it just says, okay, 2 root minus 1, 2 root 3, virtually the same thing. So we can do all the same rules with complex numbers as we can with surds. So the first thing we'll do is we'll look at how do we add and take away complex numbers. So I just want to do a few examples. Again, you might be able to pause it and try them yourself. So 2 plus 5i, that's one complex number. And I'm going to add that to 7 plus 3i. Well, I can add these terms here. 2 add 7 gives me 9. I can add these terms here. 5i add 3i gives me 8i. Just like we could with surds. Okay, 2 minus 5i, take away 5 minus 11i. Well, the first thing I do here is just expand this bracket. So 2 minus 5i, take away 5, minus the minus makes a plus, so plus 11i. Now we can combine them. 2 take away 5, it's minus 3, minus 5i plus 11i, or minus 5 plus 11 is 6, that's plus 6i. Okay, we're not going to times complex numbers or divide complex numbers yet. Let's look at how we can times and divide them by real numbers. So let's have 2 times 5 minus 8i. Well, just like we could with surds, I can do 2 times 5, get 10, and 2 times minus 8i to give minus 16i. Yeah, just like I would if I was something like root 3. And then 10, add 6i divided by 2. Well, since dividing by 2 is the same as times them by half, I can times both of these terms by half just by expanding. So I can do 10 over 2 plus 6i over 2, which gives us 5 plus 3i. Okay, now normally when we talk about numbers in algebra, we tend to use stuff like x's and y's or a's and b's. When we talk about complex numbers, we tend to write complex numbers as z or w, letters like that. And we tend to write the two different parts of it as the real part we normally call a, and the imaginary part we normally call I. Yeah, so the rule is if I add two of them together, I add the real part together, add the imaginary part together, same for taking away. And if I times it by a real number, I just times both terms by the real number. And if I divide by a real number, I just divide both terms by the real number. Okay, now you're ready to practice the questions now. So practice questions and then just check your answers to see if you managed to get them right. If you didn't, try and come up with a question about why you didn't get them right so you can fix them yourself. And then tune in again for section 5.